Okay. In last video we have discussed single slit diffraction pattern. Okay. That is we have one slit of width B, right? Then we have taken parallel beam of rays or plane wave as incident wave. Then we got some diffraction. Some diffraction pattern on the slit that shows the nature like this. Okay. This is our central maxima. Okay. This is our central maxima. Okay. Then if I take the point here, that is the condition for first minima, secondary minima. Okay, I can say our minima, first minima, secondary minima. These are secondary maximas, So I want to now you got the intensity distribution that we have found I is equal to I0 sine square beta by beta square, sine square beta by beta square. This gives intensity distribution. Okay, but then here beta is equal to this pi by lambda or pi b sin theta by lambda. Okay. That in last video we have derived this equation for intensity. So in this class what we are going to do is we have to find out the condition for maxima, minima, or where should we get our minimas and secondary minimas and secondary maxima. See in this figure, this is our central maxima, okay. Then this is our first minima, first secondary maxima. Here similarly you will get the similar point. Here also it's a minima, secondary maxima, secondary minimas, okay. Now we have to find out the condition for first minima, then we will find out the condition for secondary maxima, okay. Then the diffracted angle corresponding to what our secondary minima is, here I have taken theta. Okay, in this axis actually this is as a function of beta. Okay, beta it is beta is equal to pi b sin theta by lambda. Actually it is a function of theta. So at different theta you will have different beta actually. So our intensity is also a function of beta. So we have to find out at what beta or at what angle the you are getting secondary maxima and minima. Okay. Now the condition for central maxima we already found. That is when theta is equal to 0. That is when theta is equal to 0, beta is also becoming 0. Then theta tending to 0, beta is also tending to 0. Okay. Then I is equal to I0 sine square beta by beta square when beta tending to 0. Okay. We know when beta tending to 0, sine beta by beta gives you 1. So you are getting I is equal to I0. Oh, that is a condition for first maxima. Okay. Now the thing is first maxima is not now the first minima, but is the condition first minima, secondary minima, then secondary maxima. So what about minimum? So at minima we know I should be 0. I is equal to 0 at minimum. Okay, at minima here I is equal to 0, or this function should be minimum at some value of beta. See, when beta is equal to 0, sine 0 is 0, but at that time beta is also equal to 0. So sine 0 by 0, again the limit tending to 0, sine 0 by 0 is equal 1. So that is the condition for central maxima. That is not the condition for minima. Okay. Now when beta is equal to m pi, actually the sign becomes 0. That time you will get I is equal to 0. Other than 0, means beta is equal to 0. That is beta is equal to m pi. Okay, m means m, here I mean m not equal to 0. Sure, because when m is equal to 0 you are getting maximum point, but here m not equal to 0 and it is equal to plus or minus 1 comma plus or minus 2 comma plus or minus 3 comma etc. See, when m is equal to pi, so what will be the I? Sin pi is equal to 0. Okay. Then in denominator it is what? Pi. So no problem. So when n is equal to 2 pi, again sin becomes 0. Okay. Now correspond, then I can say, so this is the point where it is minimum. So in this case I can say beta is equal to what? Beta is equal to pi. So first minimum. Then beta m is equal to 1. Then here it is beta is equal to what? Minus 1, right? This is symmetric point in the lower region. Okay. Okay, so beta is equal to pi and plus pi and beta is equal to minus pi are the first condition for the minimum. Then 2 pi, 3 pi, etc. will be the same in means minima you will get. Okay. Now, so we have to find out what will be the theta in that time. Now we got the idea. Beta is equal to m pi will give you the what? Minimum. So beta we know it is equal to what? Pi b sin theta by lambda. Okay, pi b sin theta by lambda equal to what? M pi. That means pi cancel, pi cancel. So sin theta is equal to, this implies sin theta is equal to m lambda by, see, m lambda by b. Okay, that is when m is equal to 1, theta is equal to sine inverse, right, lambda by b. Very important. When theta is equal to 1, m is equal to 1, sin theta is equal to lambda by b, then theta is equal to sine inverse lambda by b, and actually for sine inverse lambda by b and sine inverse plus lambda by b and minus lambda by b for getting minimum. Okay, comma theta is equal to sine inverse minus lambda by b. Also, at this angle also you are getting minimum. Okay, but then theta is equal to sine inverse lambda by b, right? Now, so here the theta is actually lambda by b. Here also the theta is actually here also the theta is equal to minus lambda by b, right? So our central maxima is confined in this region. That is when theta changes from minus lambda by b to plus lambda by. So to actually the angle total theta is what I can say angle theta is equal to 2 theta. 2 theta means this the angle between the first secondary minima and on the upper side and first secondary minima or first minima in the bottom side. That is the angle with that is the angle 2 theta, that is given by lambda by b minus lambda by b means the width is 2 lambda by b. See, lambda by b plus lambda by b. Okay. So our central maxima actually confined in this angle to lambda by b. Actually the angle between the central maxima and adjacent minima will be lambda by b. Same way, but the width of the central maxima is actually the angle between this minima is actually 2 lambda by b. So suppose you want to in some problems they will ask what is the width of the central maxima. Width of the central maxima. That time you have to find out the angle between the first minimas in both sides. Okay, that is our angle 2 lambda by b, and you have to multiply this in diffraction case theta will be very small actually. Now you can take this is actually theta is equal to, I have taken lambda b by b as the theta because when theta is very small, sin theta is equal to what? It is almost equal to lambda by b. Okay, sin inverse lambda by b is equal to lambda by b. That's why here we have assumed theta is very small. So we have the central maxima, the angle between these 2 points are 2 lambda by b. Suppose somebody asks what will be the width of the central maxima. If somebody asks width of the central maxima, then this will give the arc 2. Actually 2 theta will give you arc by, you can take arc by radius condition here. So suppose the width is x, then I can say now the distance between, right? Now the distance between the slit and our screen is say d. Okay, say d. Then I can say what? The width of the central maxima x is equal to actually or the equation 2 theta is equal to x divided by this d. Okay, then what? X is equal to 2 theta d. That means what? 2 theta d means 2 theta by d is equal to, x is equal to 2 into theta is what? Lambda by b. Lambda by b into d. Okay. So lambda d by b. That is the width of the central maxima. Suppose we want to calculate this much distance only. So means what? Central maximum to one of the minima. Width between the central maxima to one of the minima. That is actually like bandwidth. Okay, that will give you x by 2. That is x by 2 is equal to lambda d by b. See, you remember this equation in reference, a similar, somewhat similar equation, that beta is equal to lambda d by d. Instead of b, we have taken what's the distance between the two slits actually. Okay, here now it is the width is lambda d by b. Okay, b is actually the width of the slit. So that is the distance between these 2 points, minima and maxima. Here, okay, up to lambda by b. So then the condition for so next what minima, where should be the next minima it is. Now we have given m is equal to what? You give what? 2 lambda by b. Then you will get 2 lambda by b here. Then here also you have to take 2 lambda by b here. Okay. Similarly, you can find out what is the different maxima and minima. Okay. Now see the condition. What you get actually will be pi by lambda b sin theta is equal to m pi. Okay, that means b sin theta is equal to, what is the condition? Here we will write once more. Okay. Okay, but here also you can write. So that means here I am writing b sin theta is equal to, right, what, m lambda. This also you have already studied the similar expression. You can say the condition for minima, or you can say the condition, here you are finding out where the theta is, but the condition for minima you can say here from this equation, that is pi by lambda, that is beta is equal to m by the is the condition for minima. That can be written like this: pi beta is equal to pi b sin theta by lambda is equal to m pi. So pi will be cut, then lambda will go here. So that means b sin theta is equal to m lambda is the condition for minima. Okay, in interference you have seen actually what is b sin theta. B sin theta is actually the optical path difference between the first point source and last point source. Okay, that means b, if you take theta, okay, this is our theta, then b sin theta will give you the optical path difference between the first and last, actually b sin theta. So in interference, what was your condition for maxima? See, I am going to write this. So we have to take only one condition. I think you understood this one. So our condition becomes b sin theta is equal to what? M lambda. Okay. In interference, two double slit experiment, Young's double slit experiment, you have taken what? The point P is taken, this distance between the two slits is, say, is D. Okay, then this will be the sine. Then you have find the, this is our optical path difference, d sin theta is equal to m lambda gives what? Maximum. Okay, maximum condition. In interference, d sin theta is equal to m lambda gives condition for maximum. That is very important. But at the same time, in diffraction, the condition for maxima is condition for minima is b sin theta is equal to m lambda. B you can write d also. D you can write d means what? That is the here is the distance between the slits. Here is the our slit width. Okay. Now why it's so? That the interference maximum condition double slit d sin theta is equal to m lambda. Optical path difference m lambda multiple ആവും. Okay, same time in diffraction what minimum condition. This is condition for minimum. That is very important. Minima where m is m not equal to 0. That is very important. Is equal to plus or minus 1, 2, etc. Okay. Plus or minus 1, 2. So with a maximum condition, the maximum that we know when the optical path difference in the order of lambda, the m is equal to 0 it starts, because optical path difference between these two waves are 0 means that is going with the same, they are in same phase. Lambda means also it is like going with the same phase. Okay, so that you have already know, you know all this case. D sin theta is equal to m lambda will give you the maximum. But here in diffraction, the b sin theta is equal to m lambda is minimum condition, but m not equal to 0 or indeterminate. Why so? Now, how we are going to explain this condition in diffraction? See, you can see. This is our what? Diffraction slit. This is our theta. This is our b sin theta, right? Okay. See, what happens is b sin theta is equal to lambda. It's our condition for minimum here. That we got from this equation. That we have found the condition for minima is b sin theta is equal to lambda. Okay. Now, what is your problem is, see, think of b by 2. Optical path difference between the first point and last point is lambda. Okay? Okay, that I understood. So now I am dividing this slit into two. Then I divide it. So if I take the point, one of the point from the upper half and other point from the lower half, which is the first point. Okay, first point source in the lower half. This one and this. Okay, this point source. Actually, we are interfering all the waves at our reference point where we are considering this point. So, ഇപ്പോൾ ഞാൻ ചെയ്തിരിക്കുന്നത് വെച്ചാൽ ഇതിനെ രണ്ടായിട്ട് ഡിവൈഡ് ചെയ്തിരിക്കുകയാണ്. അപ്പോൾ ഒരു പോയിന്റ് സോഴ്സ് എന്നുള്ള വേവ് എന്താണ് ഏറ്റവും മുകളിൽ ഫസ്റ്റ് പോയിന്റ് ചൂസ് ചെയ്തു. സെക്കൻഡ് എന്ന് പറയുന്നത് സെക്കൻഡ് ഹാഫിലെ ഫസ്റ്റ് പോയിന്റ് ആണ് ചൂസ് ചെയ്തത്. സോ ഐ ക്യാൻ സേ the gap between these two point sources b by 2. Okay, b by 2. Then the corresponding path difference between these two point sources or path difference between the waves emitting from these two point source will be what? b sin theta will be b sin theta is the path difference between the first and last, but here it is we have divided into two. So first and half on it. Half is the point on the lower half, but it is the first point. Okay, first point source. So it will be b by 2 what? b by 2 sin theta. Okay, b by 2 sin theta. In such case, b by 2 sin theta, b sin theta is equal to lambda. However, the b by 2 sin theta it should be what? Lambda by 2. Okay, lambda by 2. So, this optical path difference between first point ഈ ഹാഫിലുള്ള ആദ്യത്തെ പോയിന്റ് തമ്മിലുള്ള പോയിന്റ് സോഴ്സിന്റെ അല്ലെങ്കിൽ വേവ്സിന്റെ ഇടയിലുള്ള ഒപ്റ്റിക്കൽ പാത്ത് ഡിഫറൻസ് എന്താണ്? ലാംഡ ബൈ 2 ആണ്. അപ്പോൾ നമ്മൾ ഈ ഒരു പോയിന്റ് കൺസിഡർ ചെയ്തു. സോ യു കൺസിഡർ എനി പോയിന്റ് ഓൺ ദി സ്ക്രീൻ. Okay, so any point means minima point. Here it is. Okay, here I am taking first minima. Okay, first minima യുടെ കേസിൽ ഇവിടെയുള്ള ഒരു വേവ് വരികയാണെങ്കിൽ എമിറ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ തീർച്ചയായിട്ടും ആദ്യത്തെ സെക്കൻഡ് ഹാഫിലുള്ള ആദ്യത്തെ വേവും തമ്മിൽ എന്ത് ചെയ്യും? എമിറ്റ് ചെയ്യും. അത് രണ്ടും എന്തായാലും ഇന്റർഫിയർ ചെയ്യും. ദാറ്റ് വിൽ ബി ക്യാൻസൽ. ലാംഡ ബൈ 2 പാത്ത് ഡിഫറൻസ് ആണ്. സോ ഇഫ് യു കൺസിഡർ സം നെക്സ്റ്റ് പോയിന്റ് സോഴ്സ് കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ നിങ്ങൾ സെക്കൻഡ് ഹാഫിലെ ഇതാണ് സെക്കൻഡ് ഹാഫ്. സെക്കൻഡ് ഹാഫിലെ സെക്കൻഡ് പോയിന്റ് സോഴ്സ് കൺസിഡർ ചെയ്യാം. സോ ദാറ്റ് ടൈം വാട്ട് വിൽ ബി ദ ഒപ്റ്റിക്കൽ പാത്ത് ഡിഫറൻസ്? b by 2 തന്നെയായിരിക്കും. b by 2 sin theta ആയിരിക്കും. സോ അഗൈൻ ലാംഡ ബൈ 2 ആയിരിക്കും എന്ത് പാത്ത് ഡിഫറൻസ് ഉണ്ടാവുക. സോ അങ്ങനെ ഓരോ കറസ്പോണ്ടിങ് ഈച്ച് പോയിന്റ് സോഴ്സ് ഓൺ ദി upper half have the corresponding point source on the what's lower half. Okay, അപ്പോൾ ഓരോ പോയിന്റിന് കറസ്പോണ്ടിങ് എന്തുണ്ട്? പോയിന്റ് സോഴ്സ് ലോവർ ഹാഫിലുണ്ട്. അപ്പോൾ നമുക്ക് ഇവിടുത്തെ തേർഡ് പോയിന്റ് സോഴ്സ് എടുക്കുകയാണെങ്കിൽ ഇവിടുത്തെ തേർഡ് പോയിന്റ് സോഴ്സ്. അപ്പോൾ the optical path difference between those two point source എന്ന് പറയുന്നത് again it is lambda by 2. Okay, so അങ്ങനെ എന്ത് ചെയ്തു പോകും? ക്യാൻസൽ ചെയ്തു പോകും. അപ്പോൾ നമ്മളുടെ ഈ കണ്ടീഷൻ ഡിഫറൻഷ്യൽ b sin theta is equal to lambda കണ്ടീഷൻ എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് നോട്ട് റോങ് ആക്ച്വലി. ഇത് നമുക്ക് റോങ് പറയാൻ പറ്റില്ല, കാരണം ഇതിൽ ഈ കണ്ടീഷൻ കിട്ടുന്നതാണ് നമുക്കിത്. പക്ഷെ എങ്ങനെയാണ് അത് ഫിസിക്കലി നമ്മൾ എങ്ങനെ എക്സ്പ്ലെയിൻ ചെയ്യുന്നതാണ്. സോ അപ്പോൾ ഓരോ കറസ്പോണ്ടിങ് പോയിന്റിന് ലോവർ ഹാഫിൽ ഇതാണ് ലാംഡയാണ് കണ്ടീഷൻ എങ്കിൽ ഓരോ ലോവർ ഹാഫിനും എന്തുണ്ട്? നമ്മളുടെ അടുത്ത ഹാഫിൽ ഓരോ കറസ്പോണ്ടിങ് പോയിന്റ് ഉണ്ട്. ആ പോയിന്റും തമ്മിലുള്ള ഒപ്റ്റിക്കൽ പാത്ത് ഡിഫറൻസ് ലാംഡ. അത് ആഡ് ചെയ്യുമ്പോൾ ഇപ്പോൾ 1 പ്ലസ് എന്താണ്? അതായത് a പ്ലസ് here e1 plus e2 plus e3 plus e4 ആണെന്ന് വിചാരിക്കുക. 4 പോയിന്റ്സ് ആക്കി മാറ്റി. സോ e1 plus e2 എന്ന് പറയുന്നത് ഫസ്റ്റ് ഹാഫിൽ, e3 plus e4 എന്നുള്ളത് സെക്കൻഡ് ഹാഫിൽ. e1 ഉം e3 ഉം ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ അവർ തമ്മിൽ ലാംഡ ബൈ 2 ആണെങ്കിൽ അത് എന്തായാലും ക്യാൻസൽ ചെയ്തു. അപ്പോൾ e2 ഉം e4 ഉം ലാംഡ ബൈ 2 ആയിരിക്കും. അപ്പോൾ ഇത് എങ്ങനെ ആഡ് ചെയ്താലും നമുക്ക് കുഴപ്പമില്ല. ഇതിലുള്ള e2ന്റെ ഇതെല്ലാം കൂടെ ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് റിസൾട്ട് എന്താണ് ഇമ്പോർട്ടന്റ്. ഓക്കെ, അപ്പം e1 ആദ്യം e3യുടെ കൂടെ ആഡ് ചെയ്യുന്ന പോലെയാണ് ഫസ്റ്റ് ഹാഫിലെ ഫസ്റ്റ് പോയിന്റ് സോഴ്സും സെക്കൻഡ് ഹാഫിലെ ഒരു പോയിന്റ് സോഴ്സും. അപ്പോൾ അപ്പോൾ രണ്ടും കൂടെ തമ്മിലുള്ള എപ്പോഴും എന്തായിരിക്കും ലാംഡ ബൈ 2 ആയിരിക്കും. സോ അപ്പോൾ ഓരോ കറസ്പോണ്ടിങ് ഇപ്പോൾ ഈ എൻ നമ്പർ ഓഫ് ഇതുണ്ടെങ്കിൽ അതിന് കറസ്പോണ്ടിങ് ഈ എൻ നമ്പർ ഓഫ് എന്തുണ്ടാവും സെക്കൻഡ് ഹാഫ് ഉണ്ടാവും. സോ ദാറ്റ് വിൽ ബി ആഡഡ്. സോ യു വിൽ ഗെറ്റ് വാട്ട് the 0 because the optical path difference lambda by 2 രണ്ട് വേവ്സിന്റെ ഇടയിലുള്ള path difference lambda by 2 ആണെങ്കിൽ തീർച്ചയായിട്ടും എന്തായിരിക്കും 0 ആയിരിക്കും. Okay, that you know. Okay, any the next condition. What is next condition? B sin this is equal to 2 lambda. Okay, B sin theta is equal to 2 lambda. That is our condition for minimum. Same our condition is നമ്മുടെ സ്ലിറ്റിനെ എത്ര ഡിവൈഡ് ചെയ്യണം? 4 ആയിട്ട് ഡിവൈഡ് ചെയ്തോക്ക്. 1 2 3 4 4 right. In the case of B sin theta is equal to 2 lambda. See what will be the optical path difference ഏതാണ്? ഈ പോയിന്റും തമ്മിലുള്ള optical path difference ആണ് 2 lambda. അപ്പോൾ ഈ ഒരു 1/4 ഉള്ള ഈ പോയിന്റ് സോഴ്സും തമ്മിലുള്ള optical path difference എത്രയായിരിക്കും? 1/4 of B sin theta. That means 1/4 of 2 lambda means what? Lambda by 2 ആയിരിക്കും. Okay, മനസ്സിലായല്ലോ? ഈ പോയിന്റിനുള്ളിൽ തമ്മിലുള്ള optical path difference എന്ന് പറയുന്നത് lambda by 2 ആയിരിക്കും. Okay, അപ്പോൾ ഞാൻ കൺസിഡർ ചെയ്യണമെങ്കിൽ okay, so that is n is equal to 4 ആയിട്ടാണ് നമ്മൾ കൺസിഡർ ചെയ്തത്, ഡിവൈഡ് ചെയ്തു എന്നുള്ളത്. Okay, ഇതെല്ലാം ആഡ് ചെയ്യുന്നതാണ്, പക്ഷെ ഞാൻ ഇത് എങ്ങനെ എക്സ്പ്ലെയിൻ ചെയ്യുന്നു മാത്രം പറയുന്നതാണ്. ഓക്കെ, അപ്പോൾ ഇവിടെയുള്ള ഒരു പോയിന്റും സെക്കൻഡ് പാർട്ടിലുള്ള പോയിന്റും തമ്മിലുള്ള പാത്ത് ഡിഫറൻസ് ലാംഡ ബൈ 2 ആയിരിക്കും. കാരണം നമ്മൾ ഇതിനെ എന്താക്കി b/4 ആണ് നമ്മളുടെ ഈച്ച് പാർട്ട് എന്ന് പറയുന്നത്. അപ്പോൾ ഈ b/4 ആകുമ്പോൾ ഇവിടെ 2 ലാംഡ ബൈ 4 ആയിരിക്കണം. ദാറ്റ് മീൻസ് വാട്ട്? ലാംഡ ബൈ 2 ആയിരിക്കും. b/4 sin θ എന്ന് പറയുന്നതായിരിക്കും ഇതിന്റെയും ഇടയിലുള്ള ഒപ്റ്റിക്കൽ പാത്ത് ഡിഫറൻസ്. ഓക്കെ, അപ്പോൾ ഇതിന്റെ കറസ്പോണ്ടിങ് പോയിന്റ് ഇവിടെ ഉണ്ട്. സോ നെക്സ്റ്റ് പോയിന്റ് സോഴ്സ് എടുക്കുക. സോ നെക്സ്റ്റ് കറസ്പോണ്ടിങ് പോയിന്റ് എന്തുണ്ട്? ഇവിടെ ഉണ്ട്. നെക്സ്റ്റ് എന്തുണ്ട്? എടുക്കുകയാണെങ്കിൽ ഇതാണ്. അങ്ങനെ ഈ ഒരു രണ്ട് പാർട്ടിലും കൂടി ക്യാൻസൽ ചെയ്ത് പോകും. ഓക്കെ, 0 ആയിരിക്കും. നെക്സ്റ്റ് 2 പാർട്ട് ഉണ്ട്, അതുപോലെ തന്നെയാണ് ഈ പോയിന്റും തമ്മിലുള്ള ഒപ്റ്റിക്കൽ പാത്ത് ഡിഫറൻസ് എന്തായിരിക്കും? lambda by 2 ആയിരിക്കും. So there is a complementary point in next part. Okay, so that will be cancelled. Now the condition 3 lambda means that is it will be divided into 6 part, right? അപ്പോൾ ഒരു അഡ്ജസന്റ് പാർട്ടിന്റെ ഇടയിലുള്ള ഓരോ പോയിന്റിനും ഓരോ പോയിന്റ് സോഴ്സിന്റെ എമിറ്റ് ചെയ്യുന്ന വേവ്സിന് കറസ്പോണ്ടിങ് വേവ്സ് നമ്മുടെ അടുത്ത പാർട്ടിലുണ്ട്. അപ്പോൾ അത് രണ്ടും എന്ത് ചെയ്തു പോകും? ലാംഡ ബൈ 2 പാത്ത് ഡിഫറൻസിൽ ക്യാൻസൽ. So നമുക്ക് it's a correct the condition for the what minimum. Okay, now next thing is we have to find out the what will be the condition for the maximum. That is our condition for secondary maximum, because central maximum we have already seen. Okay, the width of the central maximum എപ്പോഴും പ്രോബ്ലം ആയിരിക്കും. Okay, അപ്പോൾ നിങ്ങൾക്ക് ഇപ്പോൾ കാണാം. So first minimum condition ആണ് lambda by b ആണ്. When theta is very small, you can take sin inverse lambda by b as a lambda by b. Okay, sin theta is equal to theta. P 2 lambda by b ആയിരിക്കും നമ്മുടെ സെൻട്രൽ മാക്സിമയുടെ എന്താണ് ഇന്റൻസിറ്റി കോൺസെൻട്രേറ്റ് ചെയ്തിരിക്കുന്നത്. Okay, now the condition for maximum, that is important. Condition for maximum. Now we have some function I is equal to I0 sin square beta by beta sin square beta by beta. Now we have found the condition for minima. So we know, but we don't know when it will be the maximum. Okay, it is not a single sign function. If single sign function, you know, it is the minima will be maximum when it is m pi by 2 odd number of m pi by 2, which is sin 90 0 ആയിരിക്കും 1 ആണ്. സോ അതിന്റെ മൾട്ടിപ്പിൾ pi by 2 മൾട്ടിപ്പിൾ ആയിട്ട് വരുന്നത് ഓഡ് മൾട്ടിപ്പിൾ എന്തായിരിക്കും? 1i. But there is a factor here to beta square. So I cannot say in that point it will be what maximum. So what you have some function which is a function of some variable beta. Then you suppose you want to find out maxima and minima. So the condition is what you have to do is take what di by dβ. Because intensity is a function of beta here. Now find di by dβ. Okay, I0 is common. Then take d by dβ of sin square beta. So I take sin square beta by beta cube, right? Minus, right? Sin square beta by beta cube. Then minus 2 is the minus 2 is 1 by beta square. Then minus 2 b sin square beta, right? This is okay, fine. Then plus what else? If you do the UV method or U by V method, you can take any method. Then if I am taking UV method because I kept sin square beta here, then I take d by d beta for 1 by beta square, that is minus 2 by beta cube, plus then 1 by beta square I am taking as a constant, right? 1 by beta square, then sin square beta derivative is 2 sin beta cos beta. Okay, this is our condition. So I can write. At maxima and minima it should be 0, right? It should be 0. So 1 by beta square is common. I0 by beta square I can take outside, but since it is 0, that will be 0. And that will be multiplied with 0. That means finally you have sin square beta 2 sin beta cos beta minus 2, right? 2 sin square beta by beta equal to 0, right? 2 sin beta cos beta minus 2 sin square beta by beta equal to 0. Okay. Again 2 is also not there. Okay. Now this I can write. If I take sin beta outside, is it correct? Okay. If I take sin beta outside, then sin beta cos by sin, it is cos beta minus sin beta by beta. Okay. Now now 0 is equal to sin beta beta cos beta. Okay, we will do once more. Okay. So at maxima and minima, it is d by d beta is equal to 0. To take di by d beta of this, you take u by v function. So if you do like that, then you will get I0 is there. So 1 by beta. So we will do first sin square. 1 by beta square 2 sin beta, right? So 2 sin beta cos beta. Okay, minus 1 by beta cube into minus 2, minus 2 is the term and sin square. Okay, sin square. can take I0 by beta square, then 2I0 by beta square, then sin beta is common, sin beta cos beta minus what, sin beta by beta. Okay. So since it is 0, I can say it is 0. Okay. Now what you have to do is, I am taking cos beta here and beta here. Sin beta, this will changes to actually beta here. Okay, we can go here. This will changes to sin beta into beta cos beta minus sin beta. Then beta will be there, since our LHS is 0, that also will be cancelled. Okay, not cancelled, so it will be gone. Okay, then it is equal to, so I am equal to sin beta. Now I am taking what, cos beta on this side, then that will go to 0. Then beta minus sin by cos, that is tan beta, is equal to 0. Alright. So this is 0. So I know this is the condition for either maxima or minima. That means di by d beta is equal to 0 for maxima and minima. So we don't know which is whether it is minimum or not. But we already see what, sin beta is equal to 0. So in this, actually this equation shows either sin beta is equal to 0 or what, beta minus tan beta is equal to 0. But we have already seen in last class, last session, that for the condition for minima, it is sin beta is equal to 0. That is beta is equal to f. Just now we have seen, right? The condition for minima in this case is what, sin beta is equal to 0. Okay. So that sin beta is equal to 0 won't work for what, maxima condition. This is already we have taken. We have already taken for minima. So I can say the condition for maxima is what, beta minus tan beta equal to 0. Okay. So this equation shows either sin beta is equal to 0 is also condition for maxima or minima, or this equal to 0 is also for maxima and minima. But we have already said sin beta is equal to 0. Sin beta is equal to 0 is equal to 0 it is the condition for minima. So of course when we are assuming that beta minus tan beta is equal to 0 is the condition for maxima. So condition for maxima is beta minus tan beta is equal to 0. That is beta is equal to tan beta. See this curve. So if you draw the curve tan beta versus beta and y is equal to tan beta and y is equal to beta curve, then wherever it meets, okay, the value of these two functions will be same, then that point will give you the condition for maxima. Okay, that means if I draw the graph, y is equal to beta graph and y is equal to what, tan beta graph, the meeting point will give you the condition for maximum. Okay, so this y is equal to beta graph is actually y is equal to beta. Then this beta is okay. This is our y. Okay. Now if I draw the tan beta graph, okay, 0, pi, 2 pi, similarly minus pi, 2 pi, okay, 3 pi, etc. Okay. Now if I draw the graph for tan, the graph will be graph when it approaches 0 pi, it will go to infinity actually, the tan beta graph. This is for y is equal to beta graph. Similarly, you have this function etc. The symmetric curve is here. Okay. Similarly, you can have the function okay. See the graph. In this graph actually, in this graph it is shown the line y is equal to beta. Okay. This line shows y is equal to beta. Okay. And this graph actually shows y is equal to tan beta. Okay. Our condition for maxima is what? Beta is equal to tan beta. With the satisfy the points points we already seen. Beta is equal to 0. That is the condition for beta is equal to 0 is the condition for central maxima. Then other points will be like this. Similarly, you can have points here also. Here also the tan curve will be like this. Okay. Pi to pi and it will go tan values will approach what infinity. That's why the graph is looking like this. So anyway, the meeting point is satisfying the condition beta is equal to tan beta. So in the minima graph, it is the pi was beta is equal to pi, 3 pi, 2 pi was the condition for minima. But in the case of in the case of maxima condition, this pi 1 pi, 2 pi or pi by 2, 2 pi by 2 or sorry 3 pi by 2, 5 pi by 2, not like you are not getting the condition as entirely different from this case. That is, you can see at the point beta is equal to what? Beta is equal to the condition for maxima. First secondary maxima, it is 1.43 pi and it is 2.46 pi, etc. Okay, for some other parts also, but in this case at least you remember two values. That is when beta becomes what? 1.43 pi and 2.46 pi. This is our beta axis. This is our pi actually. Pi is actually here, but the meeting point is actually the what? It is 1.43 pi is the meeting point. Okay. Then another meeting point is actually 2. This is 2 pi. Then 2.46 pi is the another meeting point. Okay. Similarly, you can have minus 1.43 pi and minus 2.46 pi. So the condition for maxima is actually when you get beta is equal to 1.43 pi and 2.46 pi. Okay, that means beta here condition for this secondary maxima. So this theta, so this beta value will be what? 1.43 pi. Okay, this beta will be 1.43 pi. Then second maxima or secondary maxima is second law. So this is 2.46 pi. So it is a multiple of actually here 1.43 and 246 pi approximately. Okay, then this point shows the condition for maxima in this case. Okay, now suppose you want to see this graph. I hope you understood. What we I equation I is equal to I0 sin square beta by beta square. So condition for maximum minima is first derivative will give you the, or you can, but you have to exact procedure is you take second derivative and see whether it is positive or not negative. But in this case beta we don't know, so that's why we are you have to find out the beta corresponding to positive value and negative values like that. So instead of that, what we have taken is we got the condition as a equation when you take di by d beta, you got sin beta into beta minus tan beta is equal to 0. Okay, then sin beta is equal to 0 is already the condition for minima. So what we assumed is beta minus tan beta will give you the condition for maximum. Okay. So that's why I have taken beta minus tan beta is equal to 0 is the condition for maxima. But that will tell you beta is equal to tan beta. That means when the curve, when we draw the curve y is equal to beta and y is equal to tan beta curve, then the meeting point, the equation satisfy. This is the equation satisfying at the meeting point. So that points will give you the condition for maxima. So actually that points is what? When beta is equal to 1.43 pi and 2.46 pi are the meeting point of these two curves. Okay. So this is the condition for maxima, not it is m pi by 2 like that. In last case we got beta is equal to m pi for what? Minima. But in this case not m pi, it is 1.43 pi to 446 pi. Very important result. Okay. Now beta is equal to 1.43 pi. This is the first maximum equation, theta value. So you have to find out the theta corresponding to that. That is beta is equal to what? Pi lambda b sin theta. That means b sin theta is equal to 1.43 lambda. That is sin theta is equal to what? 1.43 lambda by b. That theta is equal to sin inverse. Theta is equal to sin inverse 1.43 lambda by b. Okay. So theta value corresponding to this our theta. This theta maximum, theta minimum. Okay. 1.43 lambda by b. Similarly, you can calculate what 1 point, you give 2.46 pi as the secondary maxima. Then 2 theta will give you the width of this value, or position will give you the what you can have the position, find out the position. Suppose this value is x, the x2, x1. Then x1 will give you up to this. Okay, this will. Say it is x1. Similarly, you have taken arc by radius. Okay, theta m is equal to arc by radius. Arc is x1 by this radius is the distance between the screen and our slit. Then you take d as the curve. Here also the theta is very small. You can take the sin theta is equal to theta for calculation. Okay. Then one more thing, in some problems actually, instead of giving this d, this distance between the screen and slit, you actually they will give the focal length of the f of the lens, which we are keeping just in front of the word slit. Okay. That is equivalent to say D. When we keep our watch, our lens is very close to our slit, then you can take capital D as F. So this equation becomes F lambda by D. That's all. Okay. In any case, if they have given that f value, focal length of the lens, then you have to multiply with the f instead of the capital T. Okay. So here, so we stop here.